Today we're going to be talking about absolute extreme values on a closed interval. The first thing that we have to remember is what is called a critical number, or a critical value. A critical number is a value of x in the domain of the function at which the first derivative equals 0 or is undefined. Whether we're dealing with local extrema or absolute extrema, we need to be able to find critical numbers. The next thing that we need to discuss is the extreme value theorem. The extreme value theorem says that if a function is continuous on a closed interval, it will have an absolute maximum and an absolute minimum. Guaranteed. Okay, so the question is, how do we find those extreme values? Well, we don't have to look at every value in the interval. The nice thing is, those extreme values can occur only in limited points. They're going to occur at either an endpoint or at a critical number in the interval. That makes our procedure very simple. All we need to do, and what you're going to be given in every case here, is a function and the endpoints of an interval. So what we're going to do is we're going to find the critical numbers within the interval, and then we're going to evaluate the function, not the derivative, the function itself, at the endpoints and at any critical number in the interval. The biggest y value will be your maximum, the smallest y value will be your minimum. It's that simple. Okay, so let's try a few examples. We'll start off with a very simple, almost too simple example. The very familiar function f of x equals x squared. And we'll look at that function on the interval from x equals -2 to x equals +1. Okay, now we know, first of all, that this function is continuous on that interval because it is a simple polynomial function. It is continuous everywhere. So, what is our strategy? Step 1, let's find the critical numbers. F prime of x equals 2x. We'll set that derivative equal to 0. Our only critical number is x equals 0. Is 0 on the stated interval? Yes. If it were not, we would just throw it out because we're interested only in that interval. So, now that we have the critical number and the given endpoints, all we need to do is evaluate the function at those three values of x. So we need to take f of -2, f of 0, the critical number, and f of 1. F of -2 is 4. F of 0 is 0. F of 1 is 1. The greatest y value is the maximum. The smallest y value is the minimum. Therefore, now remember, our maximum and minimum values are y values. They are values of the function. The x values are simply locations where the function takes on those values. So, our maximum value, we could write it this way, our absolute maximum is 4x. at x equals -2. Our absolute minimum is 0 at x equals 0. It's that simple. Now, granted, this was an extremely simple example, but the procedure is the same for any function over any interval. So let's try something a little bit less boring. Something that's not just a polynomial. Let's try f of x equals 10x times 2 minus ln x. And we'll investigate that function on the interval from 1 to e squared. Let's take a look at this function, first of all. The fact that we're dealing with ln x, the natural log of x, tells us that we cannot have any x that is 0 or negative. This function is defined only for positive values of x. Well, that's not a problem here because the interval we're looking at is from 1 to e squared. It does not include 0 or any negative numbers. So, first, let's take the derivative and find our critical numbers. F prime of x, we're going to use a product rule here. 10 times 2 minus ln x plus 10x times the derivative of 2 minus ln x, negative 1 over x. Let's simplify that, and we'll have 20 minus 10 ln x. The x's cancel, minus 10, so 10, 20 minus 10 minus 10 lx, so we can factor out of 10, 10 times 1 minus ln x. That will equal 0 when the natural log of x equals 1. 1 minus ln x equals 0, ln x equals 1. The natural log of x equals 1, let's rewrite that as an exponential equation. There's an understood e here. The logarithm is the exponent, so x equals e to the 1. X equals e. So there's our critical number. Is the critical number within the interval? Yes, it is. So, again, all we do is evaluate the function at the endpoints and at this critical number. F of 1 is 10 times 2 minus the log of 1. The log of 1 is 0, so 10 times 2 is 20. F of e is 10e times 2 minus the log of e. The log of e is 1, so we have 10e times 1, 10e. Now you know that e is approximately 2.7. Therefore, this value is approximately 27, greater than that value. F of e squared, 10e squared times 2 minus the log of e squared. Right, the log of e squared is 2. So you have 2 minus 2 is 0. F of e squared is 0. Again, the greatest y value is the maximum, and we know that 10e is greater than 20. The smallest y value is the minimum. So, our absolute max is 10e at x equals e. Our absolute min is 0 at x equals e squared. And that's the way we do absolute extreme values on closed intervals. That's it.